Okay, we have two formulas that we want to look at today when we talk about graphs, and those are the distance formulas and the midpoint formulas. So far we've had, one formula this semester? By formula, I mean it's something you plug into and you memorize. What was that one formula?
Quadratic formula.
Yeah, the quadratic formula. We're going to get two more formulas today. The distance formula and the midpoint formula. So, based on your knowledge of the English language, you can probably figure out what distance formula is. If you had a graph and you had two ordered pairs plotted, let me just plot two ordered pairs, there and here. So here are 2 points on this graph. If I said to calculate the distance between the two, I think most people would figure out, okay, it's that length right there. That's what I mean by distance. So I'm not really defining distance other than just stating, what is that called, a synonym, the length of that little segment there. What would the midpoint be? Well, it's the point right at the end or in the middle. What would you guess? In the middle? So the point right there in the middle, that's the midpoint. The distance is this length right here. What's the distance between these 2 points? Now, I'm going to use, each ordered pair is an XY. But I can't call both of these ordered pairs XY, because if I do, which one am I talking about? So I'm going to put little subscripts. I think this one up here on top, I'm going to put X1, Y1. Those are subscripts. X2, Y2. Those are not exponents. They're just subscripts, meaning first X, first Y, second X, second Y. Remember, ordered pairs are always in the form XY. So, stating this distance formula, given two ordered pairs, X1, Y1, and X2, Y2. If we had to name 3 ordered pairs, but using variables, we would just go, okay, the third one would be X3, Y3. It'd probably be better to say X subscript 1, Y subscript 1, X subscript 2, Y subscript 2, but I can't wrap my tongue around that. I always wind up really slurring it. That's why I just say X1, Y1, X2, Y2. Those are not squares. Those are subscripts. And here's the distance formula. It's going to look very intimidating, but I'll try to justify why it works for those of you that want to know why. There's 2 groups of people out there. Well, no, I guess there's 3 out there. There's one group that if I state a formula, they want to know why it works. There's another group that, okay, I'll learn this formula, but I don't care why it works. I just want to memorize the formula and know how to do the problems. And then there's the other group. What's the other group? Well, I guess those are the people that they don't care why it works, they're not going to learn it, and they're not going to do it anyway, okay? So, here it is. It's the square root of x2 minus x1 squared plus y2 minus y1 squared. And again, I'll justify why that is in a moment. Now, the midpoint, if you had 2 numbers and you had to average them, Could you tell me, assume I know absolutely nothing, but I know how to add and how to subtract, how to divide. Could y'all tell me how to average two numbers? Add them together and then divide by so if there's only two numbers, then you divide by 2. So you add them up, divide by 2. To calculate anything number in the middle, you just calculate the average. If you want to know the number, what number's right between 10 and 20? I think y'all can imagine that. Number right between 10 and 20 would be what? 15? 10 plus 20 is 30. Divide by 2, 15. To get a number right in the middle of two numbers, just average. So here's the midpoint formula. Average the two x's and average the two y's. Average the x's, average the y's. Let's write it out so it looks like a formula now. You're averaging the two x's, so that would be x1 plus x2 all over 2, and y1 plus y2 all over 2. And I just realized something. A student emailed me telling me she couldn't find the class lecture notes, and I was like, oh, it's under document sharing. No, it wasn't. Why didn't you tell me? No, it's not. You forgot to put it there. I did scan them and save them on my computer, and somehow I forgot to upload them. So, here are two formulas you need to have memorized for a few minutes on Wednesday, 1 week from today. So, the the midpoint formula is usually the one students think is easier. Add the x's, divide by 2, add the y's, divide by 2. The distance formula, that takes more justification, more time trying to memorize it. Let's do, there's going to be 2. 7, 8. Let's do problem number 10 first, and then we'll go back to number 9. I'm real glad that there's, sometimes when these regenerate, there's never a negative sign anywhere in it. Well, I want some negatives, so it looks like that works real good. Problem 9 has a lot of negatives. Number 10 is a good one to justify why the distance formula works. But before I justify why it works, I'm just going to work out the problem. Then I'll justify why it works. And when I start that, I'll tell y'all I'm justifying. So if you're one of those people that doesn't care why, you can just tune out. For the point P, 10, 13, and the point Q, 15, 16, find the distance, and then there's that notation, dpq, and the coordinates of the midpoint, M. So there's two things we're asked to do. Find the distance, find the midpoint. When I look at this, the stuff I pull out of the problem is those, okay, distance, 10, 13, 15, 16. When you look at what I've written, just written down those 2 points. Let's go ahead and call each one of these, give them their variable name. First x, first y, second x, second y. That's what this x1 and x2 means. Be careful when you're labeling these ordered pairs. A common mistake that students will do is they'll go x1, x2. No, no, no. Ordered pairs are always x, y. Okay. Now, we're going to just plug into that distance formula. Okay, so taking this formula, plugging these numbers into it. That's the thing about a formula. You plug into a formula. Right? But the cut point method is not a formula. You're not plugging into anything. So x2 is the blue 15. Then the black minus is from the formula. x1 is the blue 10. Now I'm up to this one. y2 minus y1. I already have the minus. y2 I put 16. y1 I put 13. Okay. Now how would I go about simplifying all of this? Well, you're going to follow that order of operations. Please excuse my dear Aunt Sally. Work inside the parentheses first. The 15 minus 10 is just a 5. We still have that black square. The 16 minus 13 is a 3. Still have that square. The 5 squared is a 25. Ooh. And the 3 squared is a 9. I'll let the colors go at this point. 25 plus 9 is 34. And here's something we haven't done in a while. Can we simplify that square root? Is there a perfect square that divides evenly into 34? Remember how we were simplifying it on our first lesson, our first homework assignment? 4, 9, 16, 25. Nah. In fact, the only numbers that divide into 34 are what? 2 and 17? No perfect square. So the distance is square root of 34. Click square root 34. If you're wondering why is that the distance, I'll justify it in a moment. And if you're not wondering why does that work, I'm still going to justify it. Now let's find the midpoint. Let's see. So to find the midpoint, you're just going to plug in. You're just averaging the x's. You add them up, divide by 2. x1 plus x2, y1 plus y2, and I think we're going to have some fractions here. Oh, wait, what? Okay. There, I'm sorry. I wrote down the problem and started plugging it in. I'd already written it down, so it's just x1 plus x2. So 10 plus 15 all over 2. 13 plus 16 all over 2. Let's see where I'm getting that. Plugging in for x1, x2, y1, y2. I'm averaging the x's, which means add them up. So what is that, a 25? Divide by 2. Doing the same thing with the y's. Add them up. Oops, that's not a 19, that's a 29. Divide by 2. Although you're not going to punch in any decimal numbers in your answers, it might make a little bit more sense if you wrote these as decimals. The 25 divided by 2, if I can play calculator, that's 12.5 or 12.5. 29 divided by 2 is 14.5. So what this is saying is The number that's right between 10 and 15 is 12.5. The number that's right between 13 and 16 is 14.5. Okay? But the thing you're going to type in will be the fraction there. The one with the fractions. I don't think it says you can type in decimals. Let me make sure. Yeah, use either integers or fractions. Be careful. 25 over 2, right arrow, comma. 29 over 2. When I type this in and hit check answer, what's going to happen? Wrong. What's wrong? It must be in the form of an ordered pair. Make sure you've enclosed your answer in parentheses. So I've got to come over here and put parentheses around this. Okay. Any questions there? No, because you can't simplify it. Because that would have, 2's not a perfect square. You could write it as square root of 2 times square root of 17, but you can't simplify either of those. It would have to be 4 times something to simplify it further. Okay? There's no perfect square. 34 divided by... Start going 34 divided by 4, decimal number. 34 divided by 9, decimal number. 34 divided by 16. Remember, you're dividing by perfect squares. Okay? Now, what I'm going to do now is try to justify what that distance formula is doing. In order to do that, you're going to need to remember some geometry. Okay, so I'm answering the question. What is the distance formula doing? Why is it actually working? What is the distance formula doing? Well, the easiest way, if someone asks you, what is the distance formula doing? Why does it work? The easiest way to answer that is to say, well, it's doing that old Pythagorean theorem from geometry. Okay, maybe that jogs some memory. Let's review what the Pythagorean theorem is. It involves a right triangle. That's a triangle that has a 90-degree angle. Right there. If you have a right triangle, the two shortest sides, the sides that form the 90-degree angle, are called legs, and I'm going to call those A and B. Okay. Does anyone remember the name for the long side that's opposite the 90-degree angle? The hypotenuse, and I'll call it C. The Pythagorean theorem says A squared plus B squared equals C squared. That's what this thing is doing. Okay? So, you see it? Let me go ahead and pull that problem that we did back up, and I'm going to plot those 2 points. Oh, they couldn't be small numbers, could they? So I'm going to draw some graph paper. This is just my x-axis and my y-axis that I'm drawing. Oh, okay, so I am drawing an x-axis and y-axis. and I'm going to plot the point 10, 13, 1, 2, 3, 4, 5, 6, 7. You're wondering, is he really going to count all the way to 10? Yeah. 8, 9. There's 10. 1, 2, 3, 4, 6, 7, 8, 9, 11, 12, 13. So let's see. Right 10 up 13. There's 1 point. And then the other point is 15, 16. 11, 12. 15. Okay. So write 15 up. Is that 16 there? Okay. So I'm calculating the distance between those 2 points. I'm going to draw in a triangle that looks like this. So right here, and here, and there. But this is the distance I want to know. There's my right triangle. So if I stick on A, B, and C, what I'm trying to find is C. Well, this is now a geometry problem. Let's calculate this horizontal leg right here. It's going from 10 to 15 on the x-axis, or if you have sharp enough eyes, then you can count the little marks. 1, 2, 3, 4, 5. A is 5. Y'all see where I'm getting a 5 there? Now what about B? If I want to calculate this length right here, it's going from 13 up to 16. Let's see, what's that length? 1, 2. Is B a 3? Is anyone following what I'm doing here? Because now I can use that Pythagorean Theorem. What I want to know is C. Why don't I write the Pythagorean Theorem like this? Instead of A squared plus B squared equals C squared, I'll write it as C squared equals A squared plus B squared. So C squared equals A squared plus B squared. So C squared, once I square the 5, I get a 25. Once I square the 3, I get a 9. 25 plus 9 is 34. What we're trying to find is C, not C squared though. So what will I do to cancel out that square and just get a C? What do I do to cancel out the square? Just a square root? You could do this, square root on both sides. The square root and the square cancel out. Now, does any of this look familiar? Well, let's look back at the way we did the distance formula. Let me see. I wonder if I can get this to point to. What if I fold the page like that? Okay. When I'm doing the x2 minus x1, notice what that's calculating. The 15 minus 10, that's calculating the horizontal leg. So the x2 minus x1 is calculating the horizontal leg. The y2 minus y1 is calculating the vertical leg. And why are the squares there? Well, that's the a squared plus b squared. That's where those squares come from. Then why do you take the square root? Well, you're canceling out the square on the c. So this little formula is really just sort of going through the distance formula each time. Sometimes students say, oh, well, I'd rather just draw it out and do it this way every time. Yeah, but suppose the numbers were a little bit bigger than 13 and 16. It was sort of hassle drawing it out with the numbers this large. Imagine if it had been 13 and 160. And they're going to count out 160 tallies and then calculate it. You'd wind up subtracting it. And that's what the distance formula is doing. Just saving you the hassle of having to count. What's this length here? What's this length there? Okay? Any questions over that for why the distance formula works? Well, let's go back and do one with negatives. Hopefully, all of you will have one problem at least that has some negative numbers in it. So, we're going to do problem number 9. Okay, so let me write it down. And then we'll do it without any justification of why it's working. So let's see. For the points P and Q, I'll just write down the P. -15, -13. And I'll write out the Q, -8, -8. Same instructions. Find the distance, find the midpoint. Okay. So, I'll label each ordered pair X1, Y1, X2, Y2, and let me go ahead and write down the distance formula. X2 minus X1, Y2 minus Y1. So it's D equals the square root of X2 minus X1 squared plus Y2 minus Y1 squared. And now we're going to plug into this. It's going to be a little tricky because of those minuses, all those negatives. X2, I'm replacing the X2 with the blue -8. Here's where it gets tricky. I'll replace the blue X1 with the blue -15, but I have the black negative from the formula, so watch out. Watch what I'm doing. Minus a negative is a positive. So notice how the blue minus is making it a plus. And it might be hard to tell the difference between the black and the blue. I should have been using blue and red maybe. Now, Y2 minus Y1 is a -13. So it's again another plus there. Do y'all see why there's pluses in the middle now on the parentheses? Even though the formula has a minus in the middle, if that next number is negative, you have that minus and negative. Now let's see. Simplifying under the square root in the parentheses. -8 plus 15. Is that going to be a 7? Squared plus -8 plus 13. -8 plus 13 is a 5, isn't it? Are y'all caught up? Are there any questions? And a square. Any questions? The 7 squared I could write as 49. The 5 squared I could write as 25. I was about to say, okay, 64, but no, it isn't. 49 plus 25 is 74. Is that one of those square roots we can simplify? Let's see, is there a perfect square that divides into it? 74 divided by 4, divided by 9, divided by 16. There's no perfect square that divides into 74. Okay? In fact, the only two numbers I can think of are 2 times 37. Neither of those are perfect squares. So we just leave it as square root of 74. Patch that in. The square root 74. And now the midpoint. Let me go ahead and write the midpoint formula down for us. Okay, so I'm now doing the midpoint formula. The midpoint formula, you add the x's and divide by 2. Add the y's and divide by 2. Add the x's, divide by 2. Add the y's, divide by 2. Oh, am I running out of room? Okay, so x1 is negative 15. x2 is negative 8. y1 is negative 3. No, it isn't. Negative 13. y2 is negative 8. Caught up with me? Negative 15 plus negative 8 is a negative 23. And we can't reduce that fraction, the negative 23 over 2. What about the negative 13 plus negative 8? Negative 21. So, if we think in terms of decimals, negative 23 over 2 is 12.5, negative 12.5. Negative 12.5 is the number right between negative 15 and negative 8 on a number line. Negative 21 over 2 is negative 10.5, 10.5. That's the number right between negative 13 and negative 8. Okay? So we come over here. Make sure you put parentheses. Heck, I'm going to use something I don't normally do. I'm going to use this little button here. My ordered pairs. What was that first one? A negative 23 over 2. And a negative 21 over 2. Any questions there? That wraps up. So, I didn't have the videos, my old videos over this posted there, so I don't know how that was an oversight. But why do we need the old videos when you can look at the new videos? Okay? So, are there any questions on that? I think we're through 10, Let me see. I'm looking to see, yeah. Number 11, I think, is where the review problems begin. Just to get it up to 15. A homework assignment should have 15 problems, or a few more. Okay? Any questions there? Let me look at the assignment. So if you're wondering, what are you supposed to be doing? At this point, everything you should be doing is right here on assignments, with the exception of the review for that first test, the paper test. Okay? That review is posted under document sharing. Okay? So, any questions on that? So, the quiz practice is a homework grade, yes.
I was on question 9. I was doing it again. It's telling me this.
Okay, let me see.
But it gives me a different set of numbers.
Oh, let me see. What's yours? Let me look at it.